title of tonight's talk, again, is Changing the Climate, the Role of Some Widely Used Agrochemicals. And we're so fortunate to have Ed Stockman, who is certainly a part of Climate Action Now and a wonderful advisor to us. Ed is a biologist, a fourth generation farmer, and he's co-founder and education director of Regeneration Massachusetts. He served as the NOFA Mass Organic Extension Educator and also served in Ecuador as a volunteer and a trainer. And he has a project on his farm in Plainfield. He calls it Organic Agrosystems Research. And there he conducts applied agricultural research. So he's out there literally in the field doing his research. Ed also co-founded Mass Right to Know GMOs and served as the education director. He's a grandfather concerned with a changing climate. And so now I would like to warmly welcome Ed to begin his talk.
Hey. Thank you again, Susan, and thank you to everyone in Climate Action, the Farming, Forest, and Food Systems Working Group for planning this presentation and organizing it and doing a lot of good activist work in Western Mass. So my talk is Changing the Climate, the role of some widely used agrochemicals. And there's a lot of agrochemicals out there that are used on conventional industrial agriculture. I'm only going to talk about some of the more popular ones. This is the field that we're looking at. On the left is a field of canola, and on the right is wheat. So we're concerned with soil, and here's a statement by an Ohio State soil scientist that's very encouraging. A mere 2%, which doesn't sound like very much, but it takes quite an effort to do this, and that's what our regeneration agriculture is all about. You could sequester 100% of all the greenhouse gas emissions if we all manage soils in a regenerative method. So that's the hope. That's what we're going to be working towards in regenerative agriculture in general. So this is a presentation overview. I want to talk primarily about 3 agrochemicals tonight. Synthetic nitrogen fertilizers. These are widely used and excessively used in the United States. And primarily I'm going to hold my discussion to the United States. I'm not really going into a global perspective on these things. The next is neonicotinoids, neonics. These are the most widely used insecticides in the United States. And then glyphosate, which is the most used herbicide, not only in the United States, but also in the world. So there's a lot to be said about these particular agrochemicals, but I want to limit our discussion tonight and our questions to impacts of these agrochemicals on our soil life, what I call the biota, what science calls the biota. So we don't want to really talk about human health or environmental health. We want to talk about climate change, and hopefully the questions that come in will relate to that. And after I talk about the agrochemicals, I'd like to do a section of what you can do to help the situation. And then I have one slide on the co-opting of regenerative agriculture by industrial agriculture, by chemical companies. So synthetic nitrogen fertilizers, this is the backbone of industrial conventional agriculture. And I have problems getting recent data on this, but in 2015, there were 14 million tons of synthetic nitrogen, just the nitrogen fertilizers, put on cropland in the United States. So it's tremendous amounts of fertilization that's being incorporated in our conventional industrial agriculture. And of course, the more tons we put down, the more money involved with all of this. The chemical companies make tremendous amounts of profit on this. So nobody in those companies are willing to give this up too quickly. There's some USD statistics on acreage. Most of the corn in the United States, soybeans, and cotton are GMO. And we'll be talking a little about that. Not what GMOs are, but how they relate to climate change. So what is conventional industrial agriculture? High inputs, a lot of inputs, everything from the types of seeds that they use, to the chemicals they use, to the machinery, and to the scale associated with it. This is big agriculture in America. Synthetic chemically dependent, very heavily synthetically chemically dependent, fossil fueled, and a major contributor of climate change. So besides producing food and fiber, which we all need, we all use, industrial agriculture also produces a wide variety of greenhouse gases, like carbon dioxide, nitrous oxide, and methane. And we'll talk a little about those as the evening goes on. So synthetic nitrogen fertilizers are produced by the Haber-Bosch process. What's interesting about Fritz Haber, he was a German, and he actually received the Nobel Prize for his process. He was called the father, he is called the father of chemical warfare. So there was a lot of the processes that he worked on had to do with chemical warfare. But he also came up with a process to make relatively inexpensive nitrogen fertilizers. So not only do these the fertilizer process consume a lot of fossil fuels, primarily natural gas, but it produces a lot of CO2, which is released into the atmosphere. As a matter of fact, the whole process has been calculated to actually have an energy consumption of 1 to 2%. So the Haber-Bosch process also requires hydrogen, and that's mostly sourced from methane, and the methane is mostly sourced from natural gas. And of course, we have the whole fracking issue with natural gas in this country right now. So there's a lot of environmental impacts associated with this. So some of that methane, some of that CO2, most of the CO2 is released into the atmosphere during production. And those greenhouse gases are actually produced quite a bit by the synthetic nitrogen fertilizer process that's used to actually produce it. So when a farmer fertilizes a field, about half the nitrogen fertilizer is lost. And this photograph shows that that fertilizer is now not only being leached off the field, it's being drained off the field. These fertilizers are very soluble. They dissolve very easily in water. And if a farmer fertilizes that field and then you get a heavy rain like this, a lot of that fertilizer will wash off, and it has the potential then to become nitrous oxide. And nitrous oxide is a very potent greenhouse gas. So synthetic nitrogen fertilizer and the soil biota, the life of the soil. So when a farmer fertilizes his field with high levels of synthetic nitrogen fertilizer, it stimulates the soil microbes to actually grow and feast on organic matter. So they're actually destroying organic matter in the process. So when this declining organic matter in the soil, because of all these microbes now that are actually feeding on this nitrogen, once that organic matter starts to decline, the ability of the soil to store organic nitrogen is severely impacted. And the nitrogen will leach away, and if it enters and eventually enter into the atmosphere as nitrous oxide. So nitrous oxide can be released in various procedures, in various forms during various events. So synthetic nitrogen fertilizer can reduce the biodiversity in the soil by, first of all, eliminating nitrogen fixing bacteria. They really get outcompeted in a soil by other organisms that like to feed on nitrogen. So this over-fertilization of synthetic nitrogen actually changes the microbial population of a soil. For years, uh, farmers and producers of synthetic nitrogen would say that it really helps carbon sequestration by fertilizing heavily these particular crops. But in 2007, there was a definitive study entitled "The Myth of Nitrogen Fertilization for Soil Carbon Sequestration," and they found out that it really doesn't help. It really uh, it actually hampers the soil's ability to sequester carbon. I'd like to talk about pesticides next. Pesticides, the word pesticide is a confusing term. People ask me about this all the time. Uh, is an herbicide a pesticide? That's what I oftentimes get. Pesticide is any chemical used to control any pest. So it can be insects or diseases or fungi, and weeds are a pest to farmers. They're a pest to gardeners. So they fit under this pesticide criteria. Nematodes, snails, slugs. I mean, there's all kinds of pesticides that control all of those creatures. So therefore, insecticides, fungicides, herbicides especially are all types of pesticides. I hope that clears that up. Maybe some of you had that problem and others don't. The first pesticide I want to talk about are neonics. And this photograph shows on the top of it is a picture of soybean seeds. The blue seeds are treated with neonics. The yellowish, whitish seeds are untreated. The bottom part of the photograph shows corn seeds. The reddish pink ones are treated with neonics and the yellowish ones are not. They have to color these seeds because farmers do not want to feed their livestock treated seeds. These are poisons that are put on those seeds. So you don't want to poison your livestock, so they put colorful signals on there. So what are neonics? Neonics are actually a family of chemicals, and there's the list of the family. I'm not going to try to pronounce those for you. I really just want you to know that neonics are not just one chemical. They're a family of chemicals. So they've got scientific names, and if you purchase an herbicide, take a look at the name. I'm sorry, if you purchase an insecticide, take a look at the names on the bags and make sure that none of these are included or chemical names that you really don't understand. And it's difficult to ask people in stores, in farm stores or garden centers about these because many of them just don't know. But these were introduced in the 1990s. Imidacloprid is the most widely used insecticide in the world. It's one of the most widely used ones in the United States as well. Neonics are neurotoxin. They work on an insect's nervous system. They're broad spectrum insecticides. They kill a broad range of insects, not just certain insects, but they will kill a broad range of insects. They kill the target insect, the insect that's really a pest, and they kill ones that aren't doing any harm at all to ones that are beneficial. They'll kill everything. They're very broad spectrum. These are water soluble. They're usually applied as a seed treatment, and that's those pictures that we saw just a little while ago with the colored seeds. Those are seed treatments or a soil drench. And what will happen is a farmer will actually go through the field and spray the field and drench the soil with some neonics, one of those neonics or combinations of those neonics. And they are persistent in the soil. Some of them can last up to 1,000 days. It's almost 3 years, 2.5 years. Great quantities of these particular insecticides are used with GMO crops. Also, GMO crops use tremendous amounts of synthetic nitrogen fertilizers. So they're big users. This is big agriculture. These are inputs that are that farmers put in their fields. It's just a normal way of farming for industrial farmers. They're also systemic. And this is a huge problem with the pesticides we have today. Maybe some of you remember Rachel Carson's book, Silent Spring. She gave us a warning back in the early 60s that these pesticides that were really coming onto the market and coming into agriculture in large quantities were a real threat to not only the environment, but to human health. And the pesticides that they had in the 60s really were topical. In other words, a farmer would spray it on the plant and the pesticide would stay on the plant. Or the herbicide, and I remember when herbicides came in the early 60s, they would ban them in between the rows of a crop, because if they sprayed it on the crop in those days, they would kill the crop as well. So they would have protections as they sprayed so the crop wouldn't get sprayed. But systemic, the ones we have today, are much more deadly, much more insidious than those pesticides that Rachel Carson dealt with. And if you haven't read her book, Silent Spring, I highly recommend it. It's pretty much of a history book today, but it really was the beginning of people taking a hard look at pesticides and pesticides in the environment and in their food. She is a real she's a real inspiration to me and an inspiration to many people who have taken a look at pesticides. I've been an organic farmer for 49 years. She's one of the people that got me thinking about what's on my food and what I want to feed my family. 49 years ago, I was a young father with a young family and was just starting out. And it's one of the reasons I went towards organic, is because I didn't want to feed my family and my customers pesticides. So these synthetic systemic pesticides now, what happens is a farmer plants a field of corn, and the corn germinates and is up a little bit, and he'll go through that field and spray Neonics or some other pesticide on it. Now, you can do it that way, or you can use it with the seed treatment. If he goes through and seeds a field of corn with corn seeds that are treated with Neonics, what happens is Neonics are very water soluble. So the soil moisture will actually activate the seed coating, the treatment on the seed, and dissolve into the water, the soil water that's right around the seed. And as the seed grows, puts out its root system, for instance, it takes up that water with the neonics and incorporates into the cellular structure of the plant. It's actually distributed around the plant by the vascular system of the plant. So the entire plant now has this insecticide in it. And that's where people, most of you have probably heard that this is a deadly family of insecticides for pollinators, for instance. What happens is the pollen contains neonics, the nectar contains neonics, and these are things that that bees feed on, and they actually take the neonics in when they're collecting the pollen and the nectar, and it impacts them to the point of killing bees and destroying hives. So these are very insidious chemicals, the systemics, and the neonics are systemic, and we're going to talk about another one later on. So the neonic family, as we just saw, has very difficult names to pronounce and to remember. And this is confusing to consumers. It's a real problem. Consumers who read labels They see these words, they see other chemical words that are very complex and very difficult to remember and pronounce. And consequently, they say, oh, the heck with it, it must be all right. It's on the shelf. It's been approved by the EPA or the state agencies. Also, it's confusing to farmers as well. And farmers don't know about these chemicals. They just take the word of the chemical salesman. The salesman says it's all right, and they use them. They use the seeds or they spray. So farmers are very busy people. I'm a fourth generation farmer. My father was a full-time farmer. His father was a full-time farmer, and his father was a full-time farmer. And the reason I'm only a fourth generation farmer is because my great grandfather came from Germany, and I have a feeling they were farmers over there as well. But they're very busy people, especially during the season when they're buying chemicals, when they're buying seeds, and they really don't have the time or the energy or the initiative or the education or knowledge to really research these chemicals. So they really believe and rely quite a bit on the chemical salesman. And of course, the chemical salesman is one of the worst people to rely on as far as getting truthful information, because they're getting the information from the chemical manufacturer. And of course, the chemical manufacturers think their products are absolutely the best and always are safe for everything, for the environment, for human health, for the farmer, for his family, for everything. So it's a sorry state. So neonics in the United States really took off around the mid 1990s. And once again, this graph only goes up to 2014. I would expect if we had one that was for the 2019 growing season, this is like 5 years out of date, I would expect that the graph is still going up. And I'll explain why that is a little later on. But this is just a basic graph showing you the pesticide use, the neonic use in the United States. And once again, this is just the United States. I'm not really talking about international use of these chemicals, even though neonics are used internationally just about as much as in the United States. So we'll take a look at neonics and the soil life, the soil biota. The scientific literature, and when I was doing my research, some of my research for this particular presentation, you find a lot of information about pollinators, and rightly so. Pollinators are essential for agriculture. They're essential for food production globally, and especially in the United States. So neonics have a tremendous impact on pollinators. It baffles me that some farmers are very resistant to regulating neonics at all. They want to be able to use any neonic anytime they want to use it, and they don't realize how critical it is for pollinators not to have neonics in their environment. So I think some farmers are coming around to that. Of course, organic growers understand these kinds of things possibly a little better because we don't use neonics. It's not something that is part of our agriculture. So this leaves a huge, not a huge, but a knowledge gap about soil invertebrates in general and how these neonics actually impact the soil ecosystem and the soil biota in that ecosystem. Much more research is needed. Research today is difficult as far as the funding of it. Lots of money that used to be around years ago has dried up. So a lot of the research money comes from chemical manufacturers who don't want you to find anything bad about their products. One of the problems with agriculture and all of this research today is there's tremendous amounts of money associated with it. And if somebody comes out with damning evidence that neonics are really bad, not only for pollinators, but for other soil invertebrates, and people stop buying it, it's huge to these chemical manufacturers. So these broad spectrum pesticides, as we've discussed previously, kill uh, the good guys as well as the bad guys. And the guys who are just there resting on a plant, really not doing any harm at all, kills all of them uh, indiscriminately. So as a seed treatment now, about 5%, a very small amount, is absorbed by the plant. Remember I said that a coated seed, when it's planted in the ground, the coating actually becomes part of the water. They're water soluble and becomes part of the root water, or the water surrounding the root, and the plant takes the neonic in. Well, 5% of it actually gets absorbed, and 95% remains in the soil. So there's just tremendous amounts of this material being used in America. In the US, it's very, very difficult to buy a GMO corn seed, and that's what most corn grown in America is GMO. Corn is usually our biggest crop. Some years it seems like soybeans just barely edge it out, but both corn and soybeans are a huge crop in the Midwest, South, West of the United States. And it's difficult to buy a corn seed that's not treated with neonics. And about 50% of the soybean seeds are treated with neonics. And of course, these are all GMO. And it can persist in the soil. We said up to 1,000 days, but that varies. It varies based on the type of soil, the water conditions, the amount of rain, the soil moisture, the microbes that are in the soil. One of the problems with doing agricultural research is there's a lot of variables associated with it that are very difficult to control. So to get a real confirmed conclusions on something is not all that easy. So consequently, a lot of this research just doesn't get done. And it needs to get done because of the impacts to the environment, the soil environment that we're talking about tonight, or human health, environmental health. So neonics exhibit extreme high toxicity to soil invertebrates, the organisms without backbones in the soil, like detritivores. And I'm going to tell you what detritivores are in a minute. Okay, what are they? They're commonly called shredders. And what they are is groups of animals that live in the soil, like millipedes, springtails. You've probably seen springtails before. Some people see them on snow. They call them snow fleas, for instance. It's another name for them. They have tremendous numbers of them in the soil. I've seen figures in the hundreds of thousands per square meter of soil. I did research on soil in undergraduate school, and I found springtails to be the dominant organism in these soils, the dominant macroorganisms, ones that you could see. Wood lice, sow bugs are another, dung flies, slugs, and many of the terrestrial earthworms are all examples of shredders. And what a shredder does, it actually takes the large particles of organic matter that are on the surface or get plowed under or get disked under or something where soil gets incorporated with the organic matter, the plant matter. And they actually take these larger particles and they break them into smaller particles. They fragment the material. So they're reducing the actual size of the organic matter that is either in the soil or on the soil at this point. It could be added material in the form of compost. It could be what they call, farmers call what remains after the corn harvest or the let's say wheat harvest, for instance, they call that material trash. Organic farmers don't look at that as trash. We look at this as potential organic material that can be incorporated into the soil and become humus eventually, and really sequester that carbon in the soil. And we've been working on sequestering carbon and building soil ever since I became an organic grower. Organic farming isn't really very different from regenerative agriculture. Organic farmers have been regenerating the soil forever. Our motto, is we want to leave it better than we found it. I farm on a piece of land that was farmed for hundreds of years by farmers here in Plainfield, and it all grew up into trees, and I had to clear it again. But I'm grateful for what they did. They farmed it at a time where there were very few agrochemicals used on this land. And I was happy to get land that was old and hadn't been farmed for a while. So those agrochemicals are no longer available for my crops. So the importance of shredders in the soil is they actually increase the surface area of the organic matter. They break up big particles into smaller particles. And they often do this by actually eating the material, and then their waste, some people call it frass, some call it feces, what they actually release from their bodies as part of their digestive process. They actually break up the organic matter into smaller particles. And what this is important about is now the fungi and the bacteria, who are really what we call the true decomposers, they actually take chemical compounds and the digestive enzymes, and they chemically convert this material that the shredders have excreted into even smaller substances and into more stable substances like inorganic carbon. And this inorganic carbon is the way that we sequester carbon in these soils. Now, if you're a chemical farmer and you're using Neonics, you're killing most of these shredders in there. So you're actually hampering the process of carbon sequestration in your soils. So the reduction of the shredders populations by neonics really reduces the efficiency of carbon capture by those soils. And here's a very simple diagram showing the decomposition, atmospheric CO2. This is what we want to pull out of the soil, pull out of the atmosphere. We want to draw it down. If we stopped putting CO2 and other greenhouse gases into the atmosphere tomorrow, we would still experience climate change because we have so much greenhouse gases up in the atmosphere already. We need to draw it down. We need to pull this out. And the best way to do this is through photosynthesis. And I think other soil presenters have talked more about this. I'm really not going to talk much about it, but pulling this CO2 out through photosynthesis, and it gets incorporated into the plant shoots and the plant roots. Some of it's going to be given back in respiration through primarily through the root systems. Root systems respire just like we do. So as these plants die, decomposition takes place, and where it says soil fauna, that's where the shredders come in. And then the microbes take over after them, and they produce a very stable form of of carbon compounds in the form of humus. All right, and then those can stay into the soils for hundreds of years, they tell me, and I'm not sure anybody really knows how long. But that's how we want to sequester carbon. One of the ways we want to sequester carbon in the soil. So with neonics and climate change, neonics are insecticides that kill insects and other soil invertebrates, the shredders, detritivores. And these shredders are key organisms in the decomposition process of organic matter. If they're not in the soil, there isn't going to be a very efficient decomposition process that leads to carbon sequestration in the organic matter of the soil. So with the killing of these shredders, it really disrupts the whole process and it's just not as efficient. The next agrochemical I want to talk about is glyphosate. Glyphosate is the active killing ingredient in Roundup. And most of you probably have heard of Roundup, and most of you now have heard about glyphosate as well. That's a farmer spraying soybeans with glyphosate. Notice not only the spray that's heading down to the soybeans, but notice behind the tractor, the kind of like the haze that's taking place. Well, that's Roundup. And that farmer on that tractor is in a enclosed seating area that oftentimes has, it filters the air that comes in there, and oftentimes is heated and air conditioned as well. The best place, one of the best places to be when you're spraying agrochemicals like glyphosate, Roundup, is on the tractor. One of the worst places to be is the neighbor of that farmer. So what is glyphosate? It's the killing ingredients of Roundup and other glyphosate-based herbicides. So if sometime if you go into Home Depot, Lowe's, garden supply stores, centers or whatever, take a look at the labels of Roundup and other herbicides in there and see if they have glyphosate as part of their formulation. There's other ingredients in there, and those ingredients make the glyphosate go into the plant much more easily and more efficiently, I've got to say. These are broad spectrum herbicides. They kill broadleaf weeds as well as grasses, very water soluble. So glyphosate kills plants and bacteria, and by preventing proteins from being produced, essential proteins in a plant. And if those plant proteins aren't produced, then enzymes can't work and the plant eventually dies. Great quantities of glyphosate are used with GMO crops. Matter of fact, many GMO crops, most of them, are genetically engineered to withstand the killing effects of Roundup or glyphosate. If they weren't, the farmer would go into his field and spray the crop and kill the crop as well. So Monsanto and other companies have genetically engineered crops to withstand the killing effects of glyphosate. So what a farmer does, he goes in, plants the GMO seeds, they come up, they sprout, they're growing, and then he goes back into the field and sprays the entire field with glyphosate, killing the weeds, but not the crop, because the crop has been genetically engineered. The genetics of the crop has been changed to withstand the killing effects of this glyphosate. Once again, it's a systemic pesticide. Glyphosate is ubiquitous in our food. If you don't know about glyphosate in your food, go to the Environmental Working Group, EWG. They've done a lot of research on testing foods for glyphosate. So take a look at this. You really need to know which foods have high concentrations of glyphosate. It's ubiquitous in food, but we're concerned tonight about the environment and in our soils. Here's glyphosate excessively used. This graph goes from 1992 to 2014 again. I wish I could get better data on this, but I just haven't found really great amounts of it. But this shows the different crops that get high concentrations of it. I hope you can read that the yellow is corn and the green is soybeans. Those are the two big crops in the United States that are genetically engineered, and they get heavy dosages of glyphosate. Wheat and cotton are other big crops, and then the rest of them are relatively small, except pasture nowadays, and hay can get it as well. There's some pasture grasses and some alfalfa that's been genetically engineered to withstand glyphosate applications. So there's tremendous amounts of glyphosate sprayed in this country. So glyphosate is not just an herbicide. It was patented in 1964 as a chelating agent. And what that does is it really binds the mineral deposits inside pipes and boilers in factories. So they used it for cleaning out the pipes of boilers and factory piping. And in 1974, Monsanto found that it killed plants, so they patented it as an herbicide. And then in 2003, they also patented it as an antimicrobial agent or an antibiotic. So it kills bacteria. So glyphosate in the soil, after years of consistent application, and boy, they've been using this since 74, but it really got used in heavy concentrations after GMO crops came in the middle of the 1990s. So it accumulates in the soil, it persists in the soil. Even plants that were sprayed with it, when those plant roots decompose, they release it into the soil, as well as other decomposing plant material. Remember, this is a systemic, so it is completely through the crop plant, but it's not killed because the crop is genetically engineered. And it's also completely through the weed, but the weeds do die and they decompose on the soil surface or under the soil if they're incorporated, and consequently they release any glyphosate that they've absorbed into the soil. USDA says the half-life of glyphosate ranges between 3 and 249 days. And that really refers to the type of soil that they're in, the moisture content of the soil, the types of microbes that are in the soil. Once again, it's a variable thing. In the US, from the years 1974 to 2016, there's been 1.8 million tons of glyphosate applied to cropland in the United States. Tremendous volumes. This is a huge profit-making chemical for Monsanto, which is now owned by Bayer. Bayer and Monsanto are still making Roundup and glyphosate. They're being sued for various reasons, but they're still making it and they're still fighting it because this is a $7-8 billion profit item for them. So it's been out for a long time, and it's amazing how little impacts are known about what it really does to the soil life, to the biota of the soil. It's also a chelating agent, which means it binds various minerals in the soil. The second point there is calcium, iron, zinc, aluminum, manganese. and they bind up those nutrients so the soil biota does not have those to grow on, which helps to kill them. So glyphosate studies have found that it really impacts the mycorrhizal fungi, the fungi that are in association with the root systems of plants. And this is how carbon flows into the soil. So it impacts those, and it impacts earthworms and earthworm reproduction. And it also leads to having more pathogenic microorganisms in the soil. More diseases are there. And the last point here is minerals actually are combined and held with this glyphosate so that the microorganisms and macroorganisms can't use them. Next thing I want to talk about is how can we influence farming, this industrial conventional farmer, so they don't use these climate changing practices. What can we do? Now, I told you a lot of negatives about soil, but we can change this as consumers because farmers grow what they can sell. If they can't sell it, they don't grow it, all right? So these GMO crops use excessive amounts of the synthetic fertilizers and pesticides. And if consumers stop buying products with GMO ingredients, then not only are they rejecting GMOs in their food, but they're also rejecting the chemicals, the agrochemicals used to grow those crops, the climate changing agrochemicals that are used to grow those crops. So if enough consumers do this, then they're going to start using organic regenerative practices because farmers are going to grow what they can sell. So that's the focus on this. Consumers need to stop purchasing food products with GMO ingredients. How do you avoid GMOs? I'm going to read through this list quickly. Educate yourself and others. Read labels. Avoid processed foods. That's where most of it is. Grow your own is always good. Buy certified organic. If you buy from somebody local, make sure you trust them. Some people have their own definitions of organic. Non-GMO verified foods. Some of these foods are actually dried with glyphosate. You've got to make sure that wheat and oat products are organic. If they're not, they can contain glyphosate. Because what happens is when a farmer plants a field of oats, he wants those fields to be all ready to be harvested all at once, because he's going to put the machines in there to harvest it all at once. So they'll go in and glyphosate the whole field. And the oat plants and the wheat plants take those up. Oats and wheats are non-GMO, so they die from being sprayed with the glyphosate. So be careful of those. And hopefully you've read the rest of them. Phase out GMO products. Don't try to empty your cupboards all at once. Phase out 1 or 2 a week and replace those with regenerative organic produced products. Take home messages, read those over. Healthy soils contain flourishing, diverse biological communities. Healthy soils are best at sequestering carbon. Soils treated with synthetic agrochemicals will never be truly healthy. They can't be. They're being poisoned by these synthetic agrochemicals. Now, pesticide companies are trying to market themselves as the solution to climate change and healthy soils. Here's some information from the Bayer Monsanto website. They're saving the earth. They're going to be sustainable by boosting soil health. Syngenta, another chemical company, they're investing in soil health. Cargill, who supplies a lot of chemical products to farmers, they want to advance regenerative agricultural practices. Let's make sure that organic regenerative is not lost with this sudden greenwashing race to hijack the word regenerative. Go to these websites and take a look at what they're doing. Here's industrial agriculture's legacy. This is a well-kept secret in America, but conventional industrial agriculture is the largest polluter in the United States. tremendous amounts of acreage get sprayed with tremendous amounts of poisons and pollutants that wash off into streams, that go down the Mississippi River and create dead zones in the Gulf of Mexico, dead zones in Lake Champlain, weeds in Lake Champlain. Lake Champlain's in trouble. Agrobiotech. These technologies are not only producing poor quality foods with allergens and reduced nutrition and pesticide residues, but they are polluting the air, water, soil, our food, our bodies, and the earth. They are really contributing tremendously to not only the burning of fossil fuels, but the production of greenhouse gases and the prevention of soil microbes and macroorganisms from actually decomposing and storing organic carbon in the soil. So these are, nobody's really talking very much about agrochemicals when it comes to climate change, but they're going to start. There's factors out there that show that this is significant. These chemicals are significant in actually impacting our climate. Regeneration Massachusetts is an organization that I co-founded. We're interested in healthy soils, carbon capturing soils. We're interested in human nutrition. We have a Facebook page right at the bottom. If you Google Regeneration Massachusetts, you'll come to our Facebook page. That Facebook page is almost daily updated with information that consumers need to know about the food that they're purchasing, about regenerative organic agriculture, about nutrition, about climate change. There's a lot of information on that. We've got it's close to 6,500 people on that particular Facebook page. I'm pretty much done with my presentation, and thank you.
Hi, everyone. My name is Carol Horowitz, and I'm a member of the Farming Forest, the Regenerative Farming Forest and Food Systems Working Group of Climate Action Now. So let's get started with some questions. Ed, can you talk a little bit about the state of legislation in Massachusetts on pesticides, glyphosate, neonics?
In December, we had a hearing with the Mass Department of Ag Resources and some legislators who requested that the Mass Department of Ag Resources do a literature study on neonics. And they hired an independent review organization who reviewed it and found the damning information that we know is out there about neonics and their impacts on pollinators. If we can regulate neonics for pollinators, we'll also be regulating them as well for the shredders that I talked about this evening. So that's in the process and in the works. We had several several glyphosate bills that were introduced during the last legislative session. And in November of 2019, we had a hearing in Boston on those particular bills with, I think there was 150 people there that testified, all kinds of testimony about glyphosate and the problems with glyphosate. And there's problems with glyphosate when it comes to pollinators as well. We didn't discuss those tonight because we're not talking about pollinators. But those bills did not get out of, did not get to the floor for a vote, but they're being reintroduced this session of the legislature, which is actually starting in February now. They extended the session. We have a 2-year session in Massachusetts. So we're going to have neonic bills, we're going to have glyphosate bills in the legislature, in the committees, and it takes years for these things to happen. It really does. The legislature receives 5,000 to 7,000 bills a session. and you've got to make your bill about neonics or glyphosate come to the top and be recognized, and really have the legislators pay attention to it. So it's a big job, but we're hopeful that something's going to happen this coming session.
Does organic food use more land to grow the same amount of food as farming with chemicals?
You know, they tell us that industrial conventional agriculture is efficient. Well, 70% of the food grown on this planet is grown by small farmers, mostly in other countries. We have big agriculture in this country. So the efficiency, the yield per acre is much lower than an organic grower who has smaller acreage and primarily grows, you know, vegetables or dairy. They're not doing the soybeans or the large acreage of field corn or wheat or those kinds of crops. But the experimentation that's taken place, they find that the yields are very comparable between organic managed land for crops like corn, soybeans, wheat, cotton, and conventional industrial. And they find that during drought conditions, because organic land is managed with, which we try to manage it and try to build soil organic matter, which holds a lot of water. So during drought conditions, organic actually outperforms the conventional agriculture. So as far as more land, you know, right now we have much more land in conventional industrial agriculture. So it's hard for me to answer that because it's really not looking at apples and apples.
How will we be able to grow enough food to feed everybody without chemicals?
Okay, that's a good question, and we always get that one. Right now, there's more food grown on this planet than we're going to need for about 10 billion people, up to I think they estimate 2050, which I'll never see, but my kids and my grandkids will. It's not a matter of growing food. What it's a matter of is interference with food systems. It's a matter of distribution. It's a matter of poverty. There can be lots of food out there, but if peasants and people don't have the money to buy that food, it doesn't matter. They're still going to go hungry. We have tremendous hunger in this country. In the Connecticut River Valley of Massachusetts, the Western Mass Food Bank tells me that 1 out of every 4 children in this valley is food insecure, which means they really don't know where their next food is going to go, where their next meal is going to come from. Now, this is in the richest country in the world, and we grow tremendous amounts of industrial conventional crops, and we still have hunger here. So hunger is more than just growing crops. It's much more complex than that. In this country, corn is our biggest crop. 45% of that corn that's grown here goes to animal feed. 40% of that corn goes to biofuels. Now, biofuels sounds like a good thing, but I've read several research studies that show it takes more energy to produce a gallon of biofuel from corn than you get from the biofuel. And also, don't think that that's not polluting, because it is. All right, so it's a complicated issue, but there is enough food grown on this planet, and mostly by small holding farmers, to feed the population of 10 billion that is projected to be here. Now, population growth is a tremendous problem, and it's definitely for another talk. So, okay.
Okay, so well, that brings me to another question. You know, that people who live in cities and poor people don't have access to affordable organic food. Even people who live in rural areas
Right.
can't afford organic food. So what other policies, so they're not always able to change things by refusing to buy it. They have to buy what's available and what
Right.
they can afford,
Yes.
right?
Yes.
So can you
That
suggest?
that is definitely a problem that I understand. When I started organic farming, I was the only organic farmer I knew. There was no organic food in stores of any kind. So in the 49 years that I've been in the organic movement, I've seen tremendous changes. You can go into quick marts, and if you look around, there's actually organic and non-GMO products in there, but it's not easy. If you live in a food desert in a city, it's difficult. We're not there yet. We need to ramp up. We need more government help to get food um, to these people. Let me just talk about food prices quickly. Americans pay for food 3 times directly and another time indirectly. We pay for food when we walk into the store and purchase it directly. We pay for it through our taxes for the billions of dollars that corn, soybean, cotton farmers get from subsidies, billions of dollars in America. Some farms get subsidies in excess of $1 million. They're big farms, but they get excess. So through our tax dollars, we're paying for food. And then through our healthcare dollars as well. And then the fourth, more indirect way that we pay for food is the externalized costs that we're leaving to the next generation with all of these pollutants that are used in agriculture today. So we need to ramp up our food system. We need to get food to inner city people who are in food deserts. We need to get farmers markets there for them, year-round farmers markets, give them access where they can walk or take a bus to get good, healthy food. We need to supplement those foods. Organic farmers don't get any of these subsidies. All right. You need to have big acreage to get it. They should be giving those subsidies to smaller people, smaller farmers who are sequestering carbon and getting their produce to people who really need that kind of a nutritional boost that you get from organic foods. Good question, though.
Will people who use neonics today switch to pyrethroids if neonics are banned? And are pyrethrins worse than neonics?
Okay. There are, I don't know what's worse. I really don't. Many of them impact the environment. And as far as human health, the research just isn't out there. For years, we were told that glyphosate is much better than Temic or atrazine or other herbicides that farmers were using. Now we find out that all of those, including glyphosate, causes cancers of various kinds. All right. So I don't know what's best. What I know is what I've been doing for 49 years is staying away from these things. I find myself giving talks about them now because I'm interested in it, and I think it's information that needs to be spoken about. But I don't know what's better, and I don't know what they'll replace it with. But right now, the threat to pollinators is enough to take neonics completely off the market. What they replace it with, I don't know, and we'll have to take a look at those when they get replaced. But the pyrethroids, pyrethrum is a natural insecticide from chrysanthemum flowers. The pyrethroids are chemical equivalents, they say, of those. But I haven't looked into them well enough to know if they're worse than the neonics. But I know neonics are very bad when it comes to pollinators and soil arthropods, relatives of the insects in the soil.
Yeah, we just have to get away from using chemicals, period.
That's the thing. That's what regenerative agriculture really does. Now, these chemical companies would want to tell you that regenerative agriculture uses all these chemicals because that's their business. This is how they make their huge profits. But you cannot have good, healthy soil by using these chemicals, especially at the levels that they're used in this country. Is just amazing, the amounts that they put on, the farms in America.
What is the effect of drifted glyphosate on yards nearby a farm or anyone who's using it? If there's no obvious plant death showing up, is there an effect?
If there's no obvious plant death, and that person isn't growing GMO crops, then it's probably to the point where it's not, the concentration isn't severe enough to cause death to the plants. But are the humans, are the animals, the livestock, the pets inhaling this? It's probably more like, and I haven't seen research on this, but if people smoked one cigarette and all got cancer, we wouldn't have a smoking problem. In the Connecticut River Valley, we grow a crop down there that kills hundreds of thousands of people a year. We still grow it. We go buy it. All that tobacco that's being grown down there. Nobody's saying anything about that. Well, you have a choice about that. You don't have to go in and buy a pack of cigarettes or tobacco of products of any kind.
If glyphosate shuts down plant proteins, does that make the plants less nutritious?
It shuts down plant proteins in the plants that they kill. In the plants that they don't kill, they've been genetically engineered to be very little changes going on. But as far as the research shows that they are less nutritious than the same seed grown organically. So how it impacts the nutrition, the genetics, the combination, I haven't seen good research on that yet. I would love to. There's a lot of research that needs to be done on all these topics that I read a lot of research, and I'm just not finding what I need when it comes to that question. But probably that's true.
Okay, I have one more question if you can answer it maybe quickly.
Okay.
Is there a reliable way to know if foods are genetically modified? Are there labels we can trust? And what is the labeling requirement?
The best that we have is certified organic. USD certified organic is the best we have, the gold standard. Now, every once in a while, you'll hear about somebody testing a little organic and finding low dosages of glyphosate in there. Well, that can be contamination that we talked about previously. The neighbor drifted some glyphosate over there, and it might have gotten incorporated into some of those crops. Not enough to kill the crop, but maybe enough for that crop to take it in. So, but certified organic is the best that we have, and I highly encourage people to do that, because when you buy that food, you're also rejecting foods with GMO ingredients, and that's the way to influence agriculture. Farmers will grow what they can sell. I learned that very early at my supper table as maybe an 8-year-old. We talked a lot about agricultural economics. That wasn't a conversation at the dinner table. It was the conversation at the dinner table. So, okay. Well, thank you, everybody. And thank you, everybody that organized this whole thing. It was very, very nicely done.
Thank you, Ed. You have so much information that we could utilize on all these different topics. And I hope that we'll be able to have another talk with you.
Sounds good.
In the future. So Ed and I are back because there were so many unanswered questions from Ed's talk last month. And Ed has kindly agreed to come back and answer a few more. So let's get started. So Ed, Can you talk about the Biden administration's climate plan as it relates to agriculture?
I don't know a great deal about it, but I have looked it over as far as agriculture is concerned. They're using the right terminology. Whoever wrote that talks about regenerative ag. I didn't see much about organic regenerative ag. So I'm concerned that the chemical companies will get in there and lobby, and we'll still have high concentrations of chemical fertilizers and pesticides used in regenerative ag. And of course, it's just a matter of how you define the whole thing. My biggest concern with this whole plan is the person who's going to be implementing it, the Secretary of Agriculture, Tom Vilsack. He was the Secretary of Agriculture under Obama, and his nickname was Mr. Monsanto. So I'm concerned about whether he's going to be capable of actually running or managing a plan that's going to be good for the soil and actually sequester carbon in the soil and actually have an impact on our global climate change that's going on. So that's my concerns. Who's going to manage this whole program and what kind of job he'll be able to do.
Okay, so now we're going to move off of that into some farming, gardening type questions. In your talk, you talked about the problems with chemical nitrogen. And so we have a question about human urine. Is that an acceptable organic substitute for chemical nitrogen?
You know, the Chinese ran a lot of their agriculture for almost 10,000 years. This is well in the past, using a lot of excrements from humans as well as from animals. In those days, we didn't have 80,000 chemicals that bombard our lives every day. Our foods are very toxic. They contain a lot of pesticides. Glyphosate is ubiquitous, not only in the environment, but in our foods. So how does glyphosate, the active ingredient in Roundup, the herbicidal weed killing ingredient in Roundup, actually come out of our bodies? It comes out through the urine. So urine could be a good acceptable substitute for some chemical nitrogen, because those are nitrogenous wastes that come out. But because our food is so contaminated with toxins, pesticide toxins and other toxins, I don't see a great deal of future for urine. Urine contains neonics as well as glyphosate. I know there are people that are using it, trying it. The question talked about processed human urine. I don't know what processed means. If they can get all of the toxic chemicals out of it, it would be something that might be used.
Thanks. And you stated in your talk that synthetic nitrogen fertilizer has an energy consumption of 1 to 2%. 1 to 2% of what?
Well, that really, this was calculated by people who know more than I do about these kinds of things, but people I trust, this is 1 to 2% of the total global energy consumption. So 1% of the total energy consumption is a tremendous amount of energy that's used to produce these nitrogen fertilizers. And of course, the more energy you use, the more CO2 that's released, the more processing of energy, fracking to get the natural gas that you need to produce this nitrogen fertilizer. So it's really 1 to 2% of the total global energy consumption.
So how do farmers or gardeners improve soil nitrogen without synthetic nitrogen? Do other forms of nitrogen cause the same reduction in soil carbon sequestration as synthetic nitrogen?
Well, if you overused manures, for instance, you could have the same kind of problem you could have with synthetic nitrogens. Generally, that's not the case. But compost, which is a very stable carbon, Very stable nitrogen, for instance, and a good nitrogen source can be used. Raw manure can be used as well. It needs to be not overly done. When you have confined animal operations, they produce a tremendous amount of concentrated manure in an area. And if you take that concentrated manure and spread it on a concentrated way on fields, you could possibly have a problem. But green manures, legumes are excellent nitrogen fixing plants in the soil. So regenerative organic farmers use various methods of supplying their crops with nitrogen.
And how about on an industrial scale? What can industrial scale farmers do instead of using agrochemicals?
What they can do is really take a look at the regenerative practices that are out there, reducing tillage or going no-till, using compost, keeping the soil growing. When you keep the soil growing, you're actually capturing nutrients that are in the soil, and then those nutrients are incorporated back into the soil during various tillage, whether it's no tillage or reduced tillage. Crop rotations, cover crops are all ways that that farmers can prevent the use of agrochemicals. Now, as far as pesticides are concerned, healthy crops resist disease and pesticides. Sick crops have many more diseases and insects that that attack them. So dealing with monocrops, we have these huge monocrop farms, and really what we're setting up is areas, large areas where insects and diseases can really take over. And this is a great habitat for insects and diseases. And year after year, we grow corn in the same place. I've watched farms around my area in Massachusetts grow corn for 30 years in a row in the same fields over and over. And in order to stop the insects and disease that have built up in those soils and in those crops, they need to spray those heavily with pesticides of various kinds. So industrial farmers, and there is industrial agriculture that's happening on a big scale that's using regenerative practices and not using the pesticides that conventional neighbors are using. So it's very possible.
What does cultivation do to shredders and fungi and earthworms?
Deep cultivation kills the shredders. It kills lots of the microbial life. It destroys other arthropod shredders in the soil. It kills earthworms. So deep cultivation really disrupts the whole ecology of soils, and that's why regenerative agriculture talks in terms of reduced tillage, shallow tillage, and also no-till. You don't want to destroy or disrupt the ecology of the soil. You want that to happen naturally, so you wind up releasing nutrients for the crop and also sequestering carbon to mitigate climate change.
How do you know if seeds that you buy have neonics, are treated with neonics? Are they in all seeds that aren't labeled organic?
Well, most garden seeds do not have neonics associated with them. It's really something that happens on a commercial, more of a commercial level. And seeds that are treated with neonics are oftentimes also treated with a colorant. So the farmers know that that seed is treated, so they don't feed that seed to any of their livestock, because now these seeds are poisonous. They're coated with a poison that can harm livestock as well as insects in the soil. So most neonics, most garden type seeds are not treated, but farm supply stores have to notify farmers that the seed is treated with neonics. There's a notification that has to take place.
If you buy a plant that's been treated with neonics, how long will the plant contain neonics and the flowers? And how long can it affect pollinators?
That's a good question. I wish I knew the answer to that. I have not seen any good research on that particular topic. Some states now are having, Minnesota, for instance, is having a system of actually labeling ornamentals as to whether they've been treated with neonics or not. But we're not doing that yet in Massachusetts. It's something that I'm a proponent of having to happen, but I haven't seen good research on how long these neonics last within the tissue of plants.
I have heard, though, that they last for not just one season.
You know, I've read that too, but I just didn't do research on it yet.
Would you assume that honey is contaminated with neonics or other pesticides?
I hate to say this, but I no longer look at honey as a good food. You can't control where bees go. And if they go and they're taking pollen and nectar from plants that have been treated with neonics, remember they're systemic. The neonics are transported around the entire plant, and that includes coming out in droplets on the leaves, as well as in the pollen, and also in the nectar. So honey, it's very difficult to produce a honey that doesn't have some contamination in it.
That's a sad statement, isn't it?
It is. It's a very
Do glyphosate additives make glyphosate more toxic?
good research that shows that many of the additives, the adjuvants they call them, in glyphosate-based products actually make it much more toxic. But those additives are really not tested because it's not the primary ingredient in these glyphosate-based herbicides. So they're just looked at as either inert, which is not true, or they're trade secrets, and they're really not revealed to the public or sometimes to the agencies that are actually testing them. So yes, the additives in glyphosate-based herbicides can be more toxic than the glyphosate, which is very toxic. So it's that's another sad comment. So
How about flowers and bakery products? Like, we have a question, is King Arthur flour free from glyphosate? Should we assume that any bread or local bakery product is contaminated with glyphosate?
we talked about, at my presentation, we talked about the fact that wheat, for instance, is actually prepared for harvest by glyphosating wheat fields to kill all of the wheat. Wheat is a non-GMO product. It's not genetically engineered to withstand glyphosate and other herbicides. So consequently, it dies when it gets glyphosated, and prepares that the whole field is dead now and it's drying, and it prepares the field for harvest. So before it dies, of course, it's taken up this glyphosate, and that's what actually kills it. So flour today, you don't know. Some flours are killed, some wheat is killed with glyphosate and some isn't. So you really don't know which flour has glyphosate residues in it and which do not. So if you really want to make sure that you're eating bread or using flours that does not have glyphosate, you've got to buy organic. Like King Arthur produces conventional flour, and they produce organic flour. We buy the organic flour from them. And organic wheat cannot be killed in preparation for harvest with a glyphosate-based herbicide. So you know it's not in the organic product, but it could be in the conventional product. You don't know unless it's been tested. And to my knowledge, King Arthur, for instance, which is more of a local flower, to my knowledge, they don't do any testing. But I'm not, they might have started it, but to my knowledge, I don't think they test.
Should we assume then that just being marked that it's not a GMO product means that it's not sprayed with glyphosate at harvest, or are those two separate things? I've always assumed that if it says no GMO, it means no glyphosate or no pesticides. Now I'm wondering.
Right. Most GMO crops, 85%, are genetically engineered to withstand glyphosate. Wheat is a non-GMO crop. Wheat farmers, there's GMO wheat in the world, but wheat farmers will not grow it because they can't sell it internationally. There's no country that really wants to buy GMO wheat. So they refuse to grow it, so they don't sell it as such. But it is a non-GMO crop, and it is susceptible to the herbicidal effects, the killing effects of glyphosate. And once again, some fields are killed that way and some aren't, and you really don't know unless it's tested. So, but yes, it's a non-GMO crop that can have glyphosate. Most GMO crops do have glyphosate. So this is a little wrinkle in this whole thing. It's, you've got to be careful. The way to get around it, the way to be sure, is to buy organic. It's the best we have.
Here's a question from one of our listeners on the talk. We are paying through our healthcare dollars for the diseases that glyphosate is linked to. Both of my parents had Parkinson's. My dad was Mr. Roundup when I was growing up in St. Louis suburbs. He was also a research chemist at Monsanto. How do we simplify the message for consumers if we're trying to educate to change the system?
Yeah, well, I'll tell you, St. Louis was the home of Monsanto when Monsanto was an American company. Monsanto now has been bought by Bayer, and they're really headquartered in Europe. But I sympathize with this person. Parkinson's is really very pesticide related. And you take this glyphosate in or other pesticides, maybe 3 times a day, depending on what you're eating. So it's not having an effect on your life right away. It's not an acute toxin, it's a chronic toxin. It takes years and years for these toxic effects to have an impact on your body, like Parkinson's disease, which mostly older people get. So glyphosate is in our food. It's ubiquitous, not only in the environment, but in our food, and consequently, it's in our bodies. Glyphosate has polluted our water, our air, our soil, the food produced in that soil, our bodies, and the earth. So it's a huge pollutant that causes lots of problems. One of the more recent ones is how it affects our gut microbiome and the impact on microbes in our bodies. We actually have more microbes that are not directly associated with the cellular structure of our bodies than cells that make up our body. So there's a tremendous population in our intestines that can be impacted by glyphosate. Glyphosate primarily kills 2 things: plants and microbes. And for years we were told that glyphosate and GMOs are safe because it doesn't impact humans. But for some reason, the chemists and biologists at Monsanto and the chemists and biologists at EPA and FDA didn't realize or forgot that we have this tremendous population of microbes in our intestines, which are impacted by the glyphosate that we eat in our food supplies. So how do we discuss this with people? The best way to discuss it is to do some research on the internet on what foods have the most amount of glyphosate associated with them, glyphosate residues, and talk to them about it. And there's articles about Parkinson's disease and pesticides, for instance. I've read some good research and some good articles about that. One of the problems is you're not going to reach everybody. And people are going to, discredit any kind of talk about this. But there's good research out there that shows that our food, the American food supply, and we eat more GMOs than any country on the planet, and consequently, we're eating more glyphosate right along with those GMO ingredients in that food. So you're not going to reach everybody, but you don't have to reach everybody either. All we have to do is reduce the amount of GMO foods that are consumed in America, and that gets the attention of corporations that are producing food using GMO ingredients, and they'll switch. And I see that happening now. GMO foods, particularly processed foods, are just they're not as popular as they used to be. They're not selling as well as they used to be. And that's getting everybody's attention in the food industry.
I should have asked you this earlier, but can you explain what GMOs are and what you think about them and if they're dangerous?
GMOs are food crops that have been genetically altered by joining the genetics of, say, a microbe with a corn plant, something that could never happen in nature. Those two could never trade genetic sequences. So I don't want to get too complicated with this question because there are books, several books written on this topic that I've read. But essentially, it's something that's no longer natural. And really what can happen is when you join those genetics together, you can have unintended consequences, like toxins can be produced or allergens can be produced. We know one thing, the quality of the food, the nutrient quality of the food in a GMO is not as good as it used to be with conventional food or organic foods. So we've got all of those considerations, toxins, the possibility of toxins being produced in this genetic combination, or various allergens can be produced. But the one thing that really is concerning to me is the pesticide residues that go right along with GMOs. GMOs have been developed to use pesticides like glyphosate, for instance. And as I said, 85% of GMO crops are genetically engineered to withstand the herbicidal effects of glyphosate. And consequently, that glyphosate actually becomes concentrated in the parts of plants that we eat, in the seeds, in the fruits, in the leaves, in the growing tips of roots, for instance. So this glyphosate actually concentrates in these areas. And then, of course, when these parts of plants are used as a food supply, we wind up with high concentrations of this glyphosate and other pesticides now. They're using other pesticides as well with GMO crops. So there's a high pesticide concentrations that have come right along with foods that actually use GMOs as their ingredients. And most of that has to do with processed foods.
Are foods required to be labeled if they're GMO?
Labeling, I worked for 7 years trying to get food labeled in Massachusetts. We went, and this was part of an organization called Massachusetts Right to Know GMOs, which I was a co-founder of. And we needed to educate the legislators about GMOs and the pesticide residues they carry. And then actually, which was a huge process. There's 200 legislators in Massachusetts, 160 representatives, and 40 senators, and they all needed to be educated. When we started this, hardly anybody knew what a GMO was or what it even meant. So after educating them, we wrote a bill that was signed by over 75% of the legislators, calling for GMO food labeling bill in Massachusetts. But before it could be passed, the federal government, which we were working on them as well, the USDA and the FDA, and the legislators, to get food labeled in Massachusetts and all around the United States. So Obama, just before he left, signed a bill calling for the labeling of GMO foods in the United States. But during that period, and after Obama was, his tenure was up, Trump was elected. Now, under Trump, he actually campaigned to do away with the EPA and to reduce the effectiveness of the USDA and the FDA. Now, he couldn't do away with those agencies, but he surely reduced their effectiveness. So they've come out with a labeling set of regulations now, which are very interesting. Everybody's heard now what a GMO is, but GMO foods are not labeled with GMO. They're labeled BE, stands for bioengineered. Nobody knows what bioengineered means. Also, you can label foods using a QR code, which means you have to scan the code to find out if that particular food contains GMO ingredients. I can just visualize the young mother with 1 or 2 kids in tow going shopping, trying to scan a food item with their phone. I mean, that's just not going to happen. So she's just going to buy this food item because she's got these kids that are in tow and she's trying to do the shopping for the week. Also, you can write, you can use a QR code, or there's a symbol. There's a symbol that says BE on it. The symbol is a nice, friendly symbol of a pasture scene that lets the consumer know that BE is a nice, friendly food, food in general, and it contains all these good, healthy, friendly food components. So is GMO foods labeled in America? I would say no. They're not labeled, so a consumer really knows. And really, there's nobody pushing this whole thing. And I'm hoping the Biden administration now will take another look at all of this. But you can imagine the Trump administration wasn't interested in this at all.
Most of GM corn and soybeans in the US are fed to livestock. Given that more and more people are switching to plant-based diets, how do we incentivize farmers and legislators to rewild and revitalize soil that will be abandoned due to this trend?
Well, I don't think the soil is going to be abandoned, that's for sure. They'll be growing something there. What the breakdown of corn, which is pretty similar to soybeans, is we have about 45% of corn grown in this country is grown for livestock feed. And this is GMO corn. About 40% of it goes to biofuels. Every one of us in Massachusetts is forced to buy GMO corn every time we fill up our car at the gas pump. Some states have, you don't have to buy uh, gasoline that has ethanol in it. But in Massachusetts, you have to. I've read 2 good studies that show that it actually requires more energy to produce a gallon of ethanol than you get from a gallon of ethanol. So it's really not a very efficient, effective way of reducing emissions by any means. So we've got 45% is livestock feed, 40% is biofuels, and what that leaves us 15% is human consumption. A lot of that goes to high fructose corn syrup, and that's used in all kinds of foods in all kinds of ways. So I don't think we're going to wind up with a lot of fallow land if people all became vegetarians or ate a plant-based diet. That'll all be filled. But I would like to see farmers be compensated for actually sequestering carbon. And there is some movement on that on a federal level, in taking, in Biden's plan for climate change, there is some movement on actually taking and subsidizing farmers or rewarding farmers for using regenerative methods that will help to improve the sequestration of carbon. So I'm not fully convinced that we're going to, when we switch from all these pastures of animals to more of a plant-based diet, that we're going to wind up with a lot of land that could be used for crops. A lot of pasture land, especially in New England, is really very hilly and very stony type soils and wouldn't be really good for row crops in general.
So last question. Massachusetts communities have been spraying a lot for mosquitoes over the past years in the name of preventing diseases. Do these sprays fall into the neonic category?
Not that I've ever seen. I mean, maybe in the past. I've only recently taken a look at this issue in the last couple of years. What they are doing that's really heinous is these pesticides that they're spraying, and they spray some years up to 2 million acres in Massachusetts. They do aerial spraying as well as land spraying. But one of the more heinous things that they're spraying is a contaminant in the pesticides, and that contaminant is one of these forever chemicals, the PFAS chemicals, the polyfluoroalkyl chemicals, which are very nasty chemicals that last a very long time. They call them forever because maybe they last forever. I'm not sure if anybody knows that yet, but they're very long. They don't break down in nature. Microbes don't break them down. They don't photodegrade in the light. They're there. And we're spraying our citizens with this, and we don't even really know what these chemicals are capable of doing. So I don't see neonics being sprayed, but I do see nasty chemical additives being sprayed. I don't know if they're additives. I've read that some of these PFAS chemicals are actually contaminants within the lining of the jugs that actually contain the pesticide that they're using to kill the mosquitoes. So aerial spraying is not a good thing. It really isn't. What we need, in my opinion, with mosquitoes is a good education of citizens. The best way to protect you from these diseases is to protect yourself from being bitten by mosquitoes, all right? Or by controlling habitat on your farm or your suburban property. And that can be done much more ecologically than aerial spraying of some chemical. So, but that's something that us farmers really don't get into.
Okay, Ed, thank you so much for coming back and answering more questions. We really appreciate it.